Okay, welcome, and now we're going to talk about cones and frustums of cones. So let's start with cones. So a cone is a pyramid-like solid with a circular base. That's really the easiest way to define it. Is it's got a pyramid-like structure, so its sides come to an apex, right? They meet at an apex, but instead of having an octagonal base, it has a circular base. So now a right cone is one where, just like a right pyramid, is where the apex is directly over the center of the circle, the center of the base. Okay, in this case, a circle. And so a right cone is what we're going to be dealing with. But again, you don't have to have a right cone. You could have a slanted cone and stuff like that. So remember, the altitude of a cone is the perpendicular distance from the apex to the base. Okay? And so the altitude is not always the same, okay, as the slant height. Okay, so, well, yeah, that's definitely not the same as the slant height. But if you have one that's tipped over, again, you're always looking at the altitude as it is the height of the cone, but it's not always going to be over the center, I guess is what I'm trying to say. But we're only going to be dealing with right cones in this class, or in this video series. So we're not going to deal with anything that's like a slanted cone, if you will, or a cone that's not a right cone. So the altitude is the distance, it's the perpendicular distance from the apex to the base. Okay, in this case, it makes a right angle with the base. The slant height, S, is the distance from the apex to the edge of the base. So this is an apex to the edge of the base distance along the surface of the cone. And then, of course, the diameter is the distance, is the diameter of the base, right? And then, of course, half the diameter is the radius of the base. Okay? And then with that in mind are the formulas that we have been dealing with for the other figures. So we've got lateral surface area. So this lateral surface area would be the pi rs. Okay. Total surface area is the lateral surface area plus the area of the base. In this case, it's going to be pi rs. And since we're dealing with a circular base, it's going to be pi r squared. Now this is as far as you need to go, as long as you remember, again, the definition of a total surface area. You can get to this part here. You don't need to do that, okay? But again, this would be the one I would focus on. And then, of course, the volume of a cone is 1/3 pi r squared h. Or, if you want to think about it, it's just 1/3 the volume of a cylinder, okay? So remember, if you remember it's 1/3 the volume of a cylinder, and you just remember the volume, what the formula is for the volume of a cylinder, you're good to go. Okay? And so now, that's what we're going to use for dealing with some of the problems we're going to deal with. Okay, have a great day.